So last time we were starting to look at logarithms. We looked at how you can change between the exponential form and the logarithmic form. We looked at some of the very basic logs that you would see on calculators, and we also looked at some of the properties, namely these four. So the first property was log to any base c of 1 would be 0. Second property was log to base c, 2c would be equal to 1. The third one was log of base c, 2c that has an exponent of x would equal x. And the fourth one was c to the exponent of log base c 2x would equal to x. So today I wanted to take a look at some of the rules and the last property of logs. So let's take a look at that property. That property is called the one-to-one property. Now this states if you have a log base c of m equal to log base c of n, notice how the bases are the same. This means that your m will be equal to the n. Now you're kind of wondering, why might this be useful? Well, I mean, this is very useful when you're trying to solve for an unknown variable. Let's take a look at an example. Let's say we have log base 3 of 3x is equal to log base 3 of 2x plus 5. Well, we have the same base on either side. If we didn't have the same base, then this would be a hell of a lot more tricky to solve. But because these are the same bases, we can simply just rewrite this without the logs. So we have 3x is equal to 2x plus 5, and then we solve it as normal. We get x is equal to positive 5. So that is the one-to-one property. Now let's take a look at some of the rules. The first rule we have is called the product rule. Now the product rule states that if you have log of any base where you have m times n, you can rewrite it as log base c of m plus log base c of n. Now the next rule is going to be the same thing, but instead of multiplication, it's going to be division. And we call that the quotient rule. So log base c of m over n will be rewritten in a similar format to this. Instead of an addition, it's going to be a subtraction. So log base c of m becomes, well, not becomes, but minus log base c of n. Now the last rule is the power rule. So if you have a log that has an argument with an exponent, we can rewrite this by taking the exponent, bringing it to the front of the log. So it looks like this, where you have n log base c of m. So let's take a look at a couple of examples. Here we have one example. So let's simplify this. We have the product rule right here. So let's rewrite these two logs as one log, which becomes log 5x. And then this log just stays there. Now we're going to combine these two logs with the quotient rule. So this becomes log of 5x over 2. So that is an example of how you would simplify something. Now let's take a look at where we're solving for something. So here we have 2 log 5 plus 1/2 log 9 minus log 3 is equal to log x. Now you have to be careful, make sure all the logs have the same bases. Luckily, for both of these examples, the bases are all the same. Otherwise, you wouldn't be able to do this kind of stuff. They have to have the same base. So what we want to do first is take a look at these logs that have the numbers that are in front. These are the exponents that have been moved. So we're just going to move them right back. So this becomes log of 25, no, sorry, log of 5 squared plus log of 9 to the power of 1 over 2 minus log 3 is equal to log x. Now, we can actually simplify these a little bit. We can actually do the calculation. So log of 5 squared will become log of 25. Now, whenever you have an exponent that is a fraction, or in this case a half, this is the same thing as doing a square root. So we're going to take the square root of 9. This is going to give us log 3. And then we just carry down the other two that we haven't worked with yet. So if we take a look, we have two of the exact same logs. We have log 3 that is positive, and then we have log 3 that's negative. Since this is positive and this is negative, we can easily just cancel them out. So now we are left with log 25 is equal to log x. Last but not least, we will use the one-to-one property to determine what our x is. So when we use that property, we figure out that our x is actually equal to 25. And there you have it. Next time, we'll be talking about the change of base rule, and we're going to be looking at how we can change our bases if we've been given some weird ones that don't appear on our calculators.